LLMs are becoming more mature and accessible, and many teams are now integrating them into common business practices such as technical support bots, online real-time help, and other knowledge-base related tasks. However, the high cost of maintaining AI teams and operating AI pipelines is becoming apparent. Maxime Armstrong and Yuhan Luo are software engineers at Dagster, which is an open-source platform for orchestrating data and AI pipelines. They joined the show with Sean Falconer to talk about running cost-effective AI pipelines. This episode is hosted by Sean Falconer. Check the show notes for more information on Sean's work and where to find him.
Yuhan and Max, welcome to the show.
Hey, nice to meet you.
Thanks for having us.
Yeah, I'm excited to have you here. So why don't we start off with just a brief introduction? Yuhan, who are you and what do you do?
Yeah, my name's Yuhan. I joined Dagster 4.5 years ago, and now I lead developer success at Dagster. And my team's goal is to ensure our users are happy with us and can get their job done effectively through the tools we provide. Before Dagster, I am a tech lead at Yelp, where I led part of the data platform team. I focused on product analytics and its automation.
Awesome. Same question over to you, Max. Who are you? What do you do?
Yeah, for sure. I'm Max. I'm a software engineer at Dagster. So working with the developer success team with Yuhan, making sure we provide tools that help developers onboard quickly with Dagster. Yeah, and previously I was at Retain AI in the region of San Francisco, where I was working on a customer success platform. I was a data engineer, a software engineer over there at the time. Yeah.
Excellent. Yeah. So, we're going to be talking about AI and some stuff around sort of, cost optimization today. And I think as companies over the last, year or so have started to move from just sort of playing with generative AI to actually building like real AI powered applications, one of the challenges they run into is simply around cost. It's expensive to train or run models. You can easily run up huge bills if you're not careful. And based on what you've seen in your experience, like what exactly in the process of building like an AI powered application is actually expensive? Is this purely the GPU cost, or are there other factors that really lead to an explosion in cost?
Yeah, that's a good question. I think training is for sure a good part of what is the cost in AI, but I think also running the models and in terms of, for example, for the LLMs, in terms of like the completions and asking all that energy or runtime from the model. So in this example, I think we can talk about the observability. This is like a key point when we talk about the cost in AI. Like I said, training is one thing, but then after, when it's done, what do we do in the data pipeline and how can we make sure that we keep track of the costs? Yeah.
Yuhan, do you have anything to add to that?
Yeah, so I would second on what Max said, training and running basically. And in terms of running, one is like actually running the job, running all the moving pieces in an AI type pipeline. But at the same time, also, making sure that you are actually aware of what's going on in pipeline, because there's so many moving pieces. A lot of things could go wrong. So observability is what, we've been pushing on in terms of AI pipelines.
And at what scale does this start to become a problem? Like, when you're building sort of, prototyping phase, is everything like manageable? And then at some like certain level, things start to potentially become a problem that you need to really pay attention to this?
Yeah, this is actually a really good question. I actually think the short answer is whenever it's all manageable. So meaning like at a scale where you cannot control all those moving pieces. So I actually think this pattern is very consistent across, the traditional software engineering or data engineering and also this new emergent AI domain. People used to talk about like big data being this problem. Like when they talk about big data, there's like different kind of V's. For example, like when it's reaching, say, a terabyte scale, this is currently large scale and it will cause problem because the big data is just unmanageable. But nowadays, I actually believe the problem is more of in this like big complexity, which comes much earlier than simply growing the volume of the data before. And with AI, I think it's getting even more complex and comes much earlier in the product development cycle. And as you mentioned, for example, even when your application or your AI model are being developed locally, you could be touching like so many moving pieces in different systems. To say, in this example, in a blog post that we wrote on a prototype it as a support bot via some, LLM APIs. And you might call to, say, OpenAI APIs, and you may collect customer data from various sources, and then you may clean it. And in the end, you may actually also want to experiment it with different prompts to see the results. And all of these don't have to come with, large volume, but them combining together becomes this complex problem. Mm-hmm. And in AI, this actually happens, very, very early on.
Yeah, I think that's a really interesting point that you make about how early in the life cycle this becomes a problem. Because like if I'm in the early stages of building some sort of web application or something like that, and I don't have any users today, then probably like my relative costs are fairly low to spin up that application and start prototyping and testing and even getting some people like playing around with it. But the amount of data that I actually need to feed into a model to be useful already supersedes probably the level of data that my simple web application that I kind of like testing is ever going to see for quite some time. So it's not about necessarily scale of users. You have essentially data scale problems from day one, even when you're in sort of that prototyping phase.
And actually, here's my hot take. So I think AI pipelines are just data pipelines. And all those prompt engineering or fine-tuning or primary data engineering. Because exactly as you said, you have enormous amount of data since day one or even day zero. So at a very high level, it is collecting data from certain contexts, from different sources, cleaning, wrangling the data to be reusable, and then feeding it back to the models or building tools on top of it. And all of these are data engineering. So, in AI, to answer the questions like at which scale it will be a problem, it's basically like at any scale, it can be a problem. And while we're in this like early in this AI subdomain, we believe that the principle still applies. And we think taking the learnings from the traditional general data or software engineering and apply here, since day one would really be helpful.
Yeah, that's interesting. And you mentioned this article that you wrote, which is about managing costs for AI pipelines using a combination of OpenAI, LangChain, and Dagster. I want to start there. So could you walk us through sort of the initial setup process for integrating those components, and what were some of the things that you were trying to accomplish in the article that you wrote?
I think in our example, we had 3 main steps. The first one was for sure how to handle the sources. So we have like a lot of data. We want to make sure we handle that properly. The second one was to handle vector search. So if we want to do some prompt engineering using the data sources, how can we achieve that in a way that it's reusable and that we can, in the data pipeline, achieve and use that properly. And then we want to for sure handle completions. In the example, we are using an LLM, we are using ChatGPT and OpenAI. Yeah, GPT-3, I would say. So yeah, I think these steps were all components in the data pipeline. So initially, we want to handle the sources. In Dagster, we have that concept, which is the data assets or software-defined assets. So basically, an asset is a piece of data that we have in the pipeline so that we can materialize it. And then after, we can reuse it in the pipeline. So initially, we wanted to represent the sources. So what we did was create a simple asset that would pull the data from GitHub. In our case, we wanted to use the documentation that we have. And then from there, we went to creating a vector search object. So we use the FICE search index to leverage OpenAI and LangChain. Mm-hmm. And so from there, it was really about making sure that when we do prompt engineering, we could use this vector search index to go with the completions and the prompt that we were receiving from users. So for example, if a user asked specifically about, let's say, our DBT integration, then we would provide that to the FICE search index. And then from there, we would help the prompt and the answer from the LLM. So it was very like a simple pipeline, but to make sure like all the components were there.
Right. Yeah. So you built like, it sounds like a RAG pipeline using data sources. Primarily, is it all GitHub, your own GitHub that you're pulling data from?
Yes, in this example, yes, it is.
Yeah. And then Dagster is essentially pulling that in and then creating the embeddings and dumping those into a vector database, in this case, Fast Index, that you're using to augment the model when someone's creating a prompt. That's kind of the general setup that we're talking about, right?
Yes, exactly.
What's the sort of size of the data in reference here?
That's a good question. We have several pages that we're pulling. So basically, the sources here are all the pages or the guides that we use in our documentation website. So in terms of the number, I believe in terms of the tokens, it was several hundred thousands of tokens. But in number of pages, I couldn't say exactly. But yeah, I think when we pulled that in the data pipeline, eventually it became a problem in terms of how do we compute all that and make sure that the tokens are not, when we train the embeddings, we don't want to retrain all the embeddings all the time when we update one piece of documentation. So that was one of the problems we addressed in that pipeline. But yeah.
How does that work? How does the update to the index work?
Yeah, so what we did was leveraging another Dagster concept. So we used the partitions for that specifically. So what we wanted to do is imagine that you're updating one piece of documentation on your documentation website, and you want to make sure that your embeddings are up to date for when you provide that to your AI model, but you don't want to retrain all your embeddings. So what we did was splitting the sources based on partitions. So we use static partitions in our case. So what we did was, for example, in our documentation, we will have a section about integrations. We will have a section about our guides, our tutorials. So we leveraged the partitions for splitting the sources. And then what we did was, if we want to refresh the FICE search index, we just rebuild it using what we had before, but we update one part of it based on the new sources. So really, it was just to make sure that we reduce the cost, because if we don't need to rebuild all the embeddings, we should not do that.
How is pre-processing and chunking of the text handled?
In our case, it was very basic. What we did, basically, we split it. I think it was around something like 1,000 tokens, the sources, and just we fed that to the FICE search index. I think in terms of pre-processing, we wanted to keep it simple. Basically, I think in our use case, the documentation website is already formatted. It's not like social media posts that you want to make sure, you remove like emojis and different things. So I think in our side, it was just a matter of feeding a correct amount of tokens when training the embeddings. So it's a very simple use case here where pre-processing is basically chunking by about like 1,000 tokens when creating the embeddings. Yeah.
Yeah, also to add on that, one is like we build our documentation based on Markdown. So it's like we have all the source files, so those are easy. And another sources that we're using are GitHub, and we also tried a little bit Slack. That's like, we kind of prototype it in different iterations. And the first iteration was like, let's just dump everything there. And then the cost was like pretty high. And then we realized actually the highest quality, sources we could use would be our docs, which basically is like requires like the shortest context window basically. And then it will go to like the GitHub. And then in the end, after we kind of start to optimize the cost, we started to drop the Slack, because we also did some, like manual work in part of our support. Like during support, we also surface stuff out from Slack to GitHub. So it turns out to be like some Slack stuff for like kind of like a diminishing return per se. So right. We ended up not using it. But that's also part of the journey. We start really just like try to dump everything, and over time, over a few iterations, we optimize the cost.
I see. And then is the cost in your case primarily like related to the input data volume. There's a correlation essentially between input data volume and overall costs. So if you reduce input data volume, then your cost goes down.
So I think there's two things. One is, yes, definitely the input data volume, and the other is also like how much like fine tuning you would do. Like, for example, as Max said, we ended up partition stuff by like basically the feature category, like DOS category. And in there, we realized the fine tuning becomes a lot lighter because they are like within certain contexts. It does not have to, provide a ton of context to the model every time. And I guess the reason why we're so like erring on cost efficiency is, one is like we definitely care about that. The other is like we kind of want to try it as a prototype and show it to like our users who's writing AI pipelines to like basically show them and demonstrate how they can build a cost-effective pipeline and using this as like really simple example.
So what were some of the things that you like learned around the cost optimization? Like what were some of the tweaks that you had to make from the original, besides reducing the input data set, but what were some of the other things that you learned to help you control costs?
Yeah, I think the main piece of optimization in this specific data pipeline was really about, splitting the sources, making sure that we don't rebuild everything. In an initial prototype, we were just, pulling all the data sources and we were rebuilding the embeddings every time. So that was like for sure the biggest optimization that we did specifically. In the end, we also want to make sure that we reuse the same, tools often in the data pipeline where we can, and we don't rebuild different, So for example, if we have like different completion assets in our pipeline, we want to make sure in our case, we use the same search index. So that would be one thing. But I think in terms of like the completions and the way we are optimizing prompt engineering, we leveraged actually the Dagster OpenAI integration that we implemented first, in which we capture the metadata, the usage metadata on OpenAI side, and we were able to make sure that we would have a look and observe the cost. I think in our case, it was mostly about the data sources. We want to make sure we're not rebuilding everything. But after, in terms of completions, I think it's about what is the template you're using. Are you providing enough context to your prompt when you're providing it to the OpenAI model? And then from there, can we reduce that also? If you're providing too many examples, maybe it's not relevant. So using the observability tools that we have, like insights in Dagster Plus, and just, making sure what are the results, the completion's good enough if we're using less examples. And if yes, could we adjust maybe the prompt template and go from there?
Yes. Can you walk me through like that process? Like how are you making decisions about, what is enough in the prompt and how does the observability tool help you make those decisions?
Yeah, it's a good question. I think, so like I said before, in this example, we are using Dagster Plus Insights, which is a tool where you see several metrics in your Dagster pipeline. And when using the Dagster OpenAI integration, the OpenAI client will capture the metadata usage, and then we will see it over there. And after, I think it's a matter of just testing your pipeline, making sure that you have like a data set that you can test against, making sure that your completions are accurate based on what is the initial question coming from the user. Then after, I think it's a matter of comparing exactly, like if I go to insights, I could create two different completion assets. And these completion assets, one could be using like one-shot inference, and the other one could use multiple shots inference. And then from there, we compare like the two sets of completions and against a test data set. Like this is mostly how we use that. And then we can see like what is the difference in terms of like accuracy that we will have in the completions based on the number of examples we provided to the prompts. So I think it's a matter of traditional AI or machine learning testing, just making sure what is your accuracy based on the data set. And then from there also use the observability tools to see what are the costs for that example.
How are you measuring the accuracy against the test set?
I think in this example, we could use different tools. Specifically, I think we will look at what is the content and what is the answer, like in the completion, like maybe the topics are related to the original question. But for sure, I think for this example, we build the data set in terms of like what would be in the documentation. So we test against like what is the proper answer in documentation.
Yeah, I would say it's more like qualitative.
So it's a manual test then?
Yeah, it's, well, two folds to the manual test. One is internally before rolling it out. Well, before putting it in front of users, we do like some, spot check. But at the same time, we also, put it in front of users, and when user sentiments, when we know the result's good.
And then in terms of like, how do you handle errors or anomalies during the like pipeline execution as you were starting to ingest these different sources? Did you run into any issues around like essentially parsing and chunking and pre-processing, or did everything work out of the box?
Absolutely. That's like the life of data engineering, right? You always got errors or like anomalies that you don't even control.
Mm-hmm.
So that's actually a big reason why we started, building this pipeline with Dagster. It's like you kind of get the native, the logs from each run. It gives you like a very comprehensive compute logs, goes into every single run. And you also break it down to like, multiple sources. You show basically a DAG, like a graph that have all the sources coming into one, operation and stuff like that. So whenever a box is read, we know what's happening, and then we can go there. So that's like troubleshooting stuff, and usually it's like troubleshooting the like my user error.
Mm-hmm.
And another interesting thing when we go on prod is like there is also anomaly detection, right? There's also like unexpected upstream errors, which don't necessarily like do anything with us, or sometimes don't even necessarily need us to fail the runs. And in Dagster, we have this concept of like data quality check, and it's called Dagster checks. So like the idea of checks is like you don't necessarily need to fail a pipeline because something may just be like unexpected, like some different format, but we'll still want the pipeline to, run. So like we'll just say checks fails, but run succeed. You need to pay extra attention to that, and then we go into and go through the whole troubleshooting cycle.
Yeah, because those are also potential like cost centers, right? Like if you have a lot of errors and anomalies that you have to deal with, or your pipeline's like breaking all the time just for sort of normal engineering things, then you have to put a person on that stuff that's like...
Yeah, totally.
Yeah.
Like when people talk about cost efficiency, cost optimization, we should talk about, the bills our finance team receive. But actually, it's also like a lot of, human capital goes into that.
Especially right now where all these tools are quite new and a lot of people are just kind of figuring it out. You're cobbling together a combination often of like stuff that you built, some open source tooling that you've pulled from somewhere, and maybe some, existing proprietary technology that you're paying for.
Right. So that's why we always feel like, orchestration should not be, or like a control plane should not be the last piece you think of. Actually, like we do the opposite. It's like the day one we think of bringing a tool that can manage the complexity. Therefore, whenever something fails, we know exactly what's wrong instead of, going through like tons of different sources and waste like days on troubleshooting all those. I guess another thing I want to echo what Max said is about the insights. So insights is actually essentially this like UI element in our cloud instance, and it actually shows you like charts over time. So, checks failure, some cost tracking that if certainly there's a dip or certainly there's a bump that we can easily capture those. And those also made our life easier.
How did you manage like the model deployment and versioning?
Yeah, that's also a really good question. We are all kind of declarative. So everything are defined in code. So, they're essentially all just versioned out of box through Git. And another thing we really liked ourselves, and as this feature called branch appointments. So basically, it's like we set it so every GitHub PR goes from to a branch, of course, and then every branch gets pushed to a kind of sandboxing-like environment to Dagster Plus. So then before you push to prod, so the idea is like you go from local and then you go to branch appointments, and that's basically the staging environment, but it's an ephemeral environment. So it's like when you could think it as a sandbox. So it's like you can do whatever with it, and it does not touch your prod environment, and it gives you basically this like integration or like small task workflow. So before you hit go live, go prod, you are actually confident that the model is deployed, properly, and all the moving pieces are like ring.
Is there a way to roll that back if you have to?
Right. Yeah. All just Git commits. You just revert a commit and things would be back.
No, I meant the model itself.
Oh, yeah.
Did you make updates?
We currently do not have the model versioning. We do save the model as like the intermediate step automatically. So whenever you want to get the previous data, it's somewhere in our S3 bucket.
Okay, got it. I see. And then one of the things that you started off talking about was how you had this, your hot take about how AI pipelines are not that much different than like a traditional data engineering pipeline. But are there unique challenges that come from building these kind of, either it's a, RAG model or pipeline or a Gen AI model pipeline, whatever it is? Are there unique parts of that you've encountered that are different than maybe what you've traditionally encountered in building a data engineering pipeline that's going to drop data down into like a warehouse or something like that?
Yeah, that's a really good question. I would say actually almost all the parts are similar, but the interesting part is like the learning curve and like the familiarity with all sorts of like different tools. Max can probably speak more about it, but to my experience, it's like actually, we also use LangChain when building this, and LangChain really helped us just making like the model comparison, like switching between model, and also like lower the learning barrier for like switching between models. So I would say that's like a big component to it, because like in traditional data engineering, it's usually like if you're using Snowflake, you're using Snowflake, and SQL is just like all the same. Whereas for those like newly AI tools, all kind of perform differently. So we have to learn every single stuff. And LangChain as a component here really help us to make things like modular and composable, and the switch cost becomes pretty low.
Yeah, it's interesting. Like if you compare, what you need to do, let's say you're building some AI application, and you're going to use a model underneath the hood to, do some AI magic. Like there's pretty big variance in terms of the quality of responses for the specific use case, which is very different than like you're hitting a database and you're running a SQL query. Like maybe there's some performance differences at certain scale and stuff like that, but it's still the same SQL statement's going to generate the same response. Exactly. And the same data is there.
And you kind of poke around and say, like, the execution plan is just like, it's all kind of deterministic, whereas AI, it's such a black box. So
it's non-deterministic, basically. So.
Yeah.
Do you see much in gains in terms of cost by changing models?
Actually, yes. So originally, we actually had this prototype really early on when the GPT-3 came out. And when we refreshed this pipeline with our OpenAI integration, the GPT-4 came out. And around the time, or actually after we released this blog post, the 4.0 came out. So it's like every time we would just like try, 1-2 parameter and change it and see the cost. So the cost from 3 to 4 went dramatically down. And it's also interesting that, the kind of qualitative sentiment analysis also went up. So, like all those AI companies are definitely doing stuff, and it seems really promising to me in both the cost-efficient way and also like making our job easier.
You may not know this, but I'm curious to hear your thoughts on, so like I could run essentially, take an open source model and run it on my own, instances. versus calling something like OpenAI's APIs where they're going to run this stuff as a managed service behind the scenes. Do you think that there's cost savings to be gained? I mean, obviously, I'm taking on a lot of responsibility to try to manage the infrastructure to run the open source model and scale it. But in the early, maybe prototyping phase where performance is less of an issue, is that a way to potentially keep costs low while I'm going through the prototyping phase?
Meaning like open source models?
Yeah, essentially run an open source model on my own like GPU cluster or even CPU cluster. Like it's going to be slow, but I could do it in order to just like test and iterate. And then once I get to a place where I'm happy, then I can do something that's more scalable where the cost goes up.
That's exactly why I mentioned then chance. Like it's just like one or two prime changing, then you go to.
Right. Yeah. So was that an iteration that you went through?
I think we probably have compared Llama. I forget. But like we did compare like a few other ones. So it's not like in the initial prototype phase, it's not like cost was not a big concern. So like we just like went straight to OpenAI.
In terms of your experience like building some of these AI powered applications, we talked a little bit about how the tool chain is it's certainly immature in comparison to other, even though like modern data stack or something like that, where you're cobbling a bunch of tools. Like, where do you see the biggest gaps right now based on your experience where that need to be addressed for people to be able to build more sort of production level AI applications?
To me, I would say it's the metadata tracking. So it's like, I don't necessarily want to treat all those models as, black box. For example, the very first step forward in the past year was like this usage tracking. OpenAI exposed more metadata about each API calls. So then this gives us basically this like platform who wants to interact with those models to have to leverage, say, we let the model users to handle the business logic themselves, but let us take care of those like pipeline or API calls, like metadata. And what's lacking in my mind is like trying to expose more, for those platforms to explore more like interesting metadata.
Any thoughts on that, Max?
Yeah, I would second Yuhan on this. I think one of the technical challenges we had when building that pipeline specifically was to make sure that when using LangChain, we would be able to capture the OpenAI metadata. So I think when using new tools, like all of these are very powerful, we just want to make sure we can use them together properly, efficiently, and then we can keep track of the cost. I think in this use case, we created beforehand the Dagster OpenAI integration, in which we did kind of like a wrapper around the OpenAI client, enabling us to capture the metadata. So basically, the challenge for us was to make sure we could use that with LangChain. It was a good thing because LangChain was ready to use that specifically, but then it was a matter of like making sure how can I use like one of these tools and make sure I can bring it in my data pipeline and leverage as much as I can, because in production I want to make sure I can keep track of what's going on. So so in our case we were able to plug the OpenAI client that we implemented, the wrapper, and it was good to go with that. But I think making sure we can leverage these tools, quite new tools, and make sure we can bring them with the observability that we want for a production data pipeline.
What about on the vector side? So you're using fast index for your embedding index, but is there a trade-off with that of relying on that versus relying on something like a more fully fledged like vector database? Or are you operating with such a small enough data set that there isn't necessarily a visible performance improvement?
Yeah, I think it would be the latter for this data pipeline. I think, like I said before, it was kind of like a few 100,000 tokens for this example. So I think it was good enough to just go with FICE. It was fast enough. And quite frankly, the cost of, just going with something else was maybe too big for this use case. So going with that solution was just the best to do. But I agree that if the input data was much greater, it would be interesting to test different approaches in terms of like the embeddings and how can we make the most of different approaches, and how can we reduce the costs for that.
What's next with this project? Is this kind of wrapped up, or are you going to be continuing to build and iterate on this?
Yeah, the project itself is wrapped up, and we do want to expand, as we write more features. We kind of use this as an example pipeline to, demonstrate and dog food the, all the capabilities that we have with other AI tools. So later on, we want to, one is like leverage our new data catalog to add more sources, like trying to add Slack in and also our support tickets, and also build on top of like the data freshness and reliability to deal with like bad or like spammy sources. So these are the things. But, at the same time, we're also exploring, we're actually using, other like AI support tools at the same time because they do better job than us making it as like our part-time projects.
How do you see like the integration of, Dagster with LangChain and OpenAI sort of continuing to evolve?
Yeah. So as I mentioned, I think the composability is actually a really big key part. On the Dagster side, we aim to be this composable single pane of glass for all your data. And while I cannot really speak deeply for LangChain, but given my experience, I think it really makes the process of building AI apps mostly via those like modular components. So when integrating with the LangChain, similar to LangChain, I think composability, and it boils down to like, one is like incremental adoption. So it's like if we can move certain stuff too, and we don't want, I believe we and, other tools, like, for example, like we are a huge believer in like incremental value delivery, and we don't want our tool to be adopted as all or nothing. We will meet users where they are. So for example, like if in the future, those tools does have a capability to like execute a model or like, run stuff, then we would, instead of all in Dagster, we would want to offer like this term called like observe, which means like you can listen to those activities in external platforms so that, for example, Dagster would know the upstream dependencies, for example, in LangChain or other platform, but still be able to manage the things that depend within Dagster, but depend on external sources. But at the same time, we don't have to necessarily kick off those jobs. And that's like a big component when we think of integration. The other components are, the second one would be like, and this phrase called like learn once, write anywhere. So LangChain actually does a really good job as like it makes switching model really easy, and we want to do it the same way. It's like sometimes user may want different tools in the same category or even switch between them. And we want our integration with AI to be like that. We want our pan to be consistent enough to lower those switch barriers, basically essentially like get users to get their job done quickly enough without learning, new things.
What needs to happen in order for that to occur?
So part of it will be like in our integration abstraction, we would build like the same pattern, same abstraction for different tools within the same category. Throughout the past year, we rolled out this tool called this like pattern or concept called pipes. That's essentially a tool, a protocol built on top of our like very basic building blocks. And basically it's like, if you want to integrate with external execution platform, that is the way to go. And then to our users, the APIs will just look the same.
Great. Well, as we start to wrap up, is there anything else that you'd like to share?
Let's see. There's some interesting thought recently in like data and AI that I may want to share. So, we recently rolled out this blog post called Rise of the Median Code. So, AI is a big topic and it will continue to be in the future. And many people think that AI will completely kind of eliminate those like human written software creation. But in our land, and I guess this also kind of comes back to this whole integration story. So it's like we believe that humans are still remaining in the driver's seat when it comes to, building software. And we caught this kind of emergent class median code. So we believe those authors are essentially the ones who own the business logics. So like LLMs and AIs cannot really author those logics like unsupervised. Mm-hmm. And we believe these jobs are not replaceable, which is also a key reason why we want our users to focus on like writing the business logics and just leave all those other, metadata moving pieces for us to handle. I thought there's like some interesting conversation going around after we kind of start to think and explore that part.
Yeah, I mean, I think that it's difficult to make almost any definitive statement about where things are going to be in the future right now because things are moving so quickly. And we always tend to sort of, I think, underestimate in the long term and, overestimate in the short term. I think like one of the interesting things that's happening right now is if you had showed most tools that exist in the Gen AI space to anybody 5 years ago, they'd be like blown away by the magic of it. But after just a year of Chat GPT, we're all like disgruntled and think that it's like like terrible and consistently like criticize the output that comes from and forget the like utility and value that it's generated.
Right. Yeah, I was about to say like 5 years is a huge understatement. It's like a year.
Mm-hmm. Yeah, absolutely. Well, Yuhan and Max, thanks so much for being here. This was great, very enjoyable. It was great to learn from your firsthand experience, how some of the things that you pulled away from this project of building, AI pipeline and some of the things that you were able to do around optimizing costs.
Thanks so much.
Yeah, thanks for having us. I've been really excited to be here.